understand by the word key value pairs. We'll talk about shuffling. We'll be talking about splitting. We'll talk about splitting. We'll talk about shuffling. We'll talk about the reduce function. I'll be talking about the final output. So it's a it's going to be an interesting class. So I'm trying to share before share. I want to share my screen. Sorry, I'm trying to share. Okay, can we all see my screen?
Yes, sir.
All right. So today we'll be working on we'll be having a class on working with map reduce, and so the word map and reduce. So how does it really work? And what's the architecture behind it? So as we know before now that the whole big data analytics or big data platform sits on the Hadoop distributed framework, and that is the ability to work on multiple nodes in parallel. So, and last week we talked about one of the main disadvantage of Hadoop is that you can't just come. Not all applications can run Hadoop, can run on Hadoop platform. So, but MapReduce is an algorithm that has a potential that can work on a Hadoop framework, and that is having the ability, especially the ability to work on multiple nodes at different times, the ability to communicate to different systems at different time, and all of them work independently, working on different logs, and they're able to get the result out. That is the real functionality of Hadoop framework. So MapReduce is one of the main components that Hadoop system will make use of. Yes, because that's the guy that does the dirty job. So after you get your data into the system, the next thing is who's going to do my data job for me? Who's going to do my data aggregation? Because the world of big data, the data is always very dirty, and you need to do some aggregation. You need to do some ETL. You need to, let's say, extract, transform, and load. So the guy responsible for the ETL process is MapReduce. Is the one that takes unstructured data type and make it structured. That's one thing this guy is good at, and is being able to bring out insight, extract a lot of things for you. So if you want to extract, for instance, now you are having maybe a web service log, and on the web service log you have over 20 parameters, and you want to just extract, say, 10 of the parameters. MapReduce will do it for you, because that's just like if it's a structured environment, it's just as if you want to select columns and say, okay, select start from this guy, and this guy, and in a structured environment. But here now you are selecting from unstructured environment. So please give me 1 minute. Sorry. Sorry for the break. So MapReduce is the guy that does the whole work for you and make it structured. And as I said earlier, from in a structured environment, you don't need to worry yourself. Just run your select star, and everything works. But in the big data world, there's a need for you to do it in a programming way, and though it's very fast, and especially the ability to work on different nodes. So now, so that's what we'll be working on today. So the objective. So we are going to explain the MapReduce framework and talk about the step to build and execute a MapReduce, the various techniques to design MapReduce implementation, the process of building joins with MapReduce, and apply the techniques to build interactive MapReduce techniques. So those are things we'll be covering today. So okay, before I move on, do we have to the 9 of us that has gotten our package? Do we also have access to the virtual machine? Do you have virtual machine installed on our system?
Yes, sir, we do.
Please, if you have virtual machine, okay. Please, if you have virtual machine on your system, just raise your hand. If you have virtual machine on your system, okay. How about? I'm not seeing hand though. So is the only one having virtual machine on the system? Please, if you have virtual machine on your system, please raise your hand. So that means, Adetoro, you don't have virtual machine on your system. Oluwatobi.
It didn't work well this morning. That's why I'm not raising my answer.
What did you say?
I said it didn't work well this morning. I had difficulty following the class. That's why I'm not raising my answer.
You have difficulty calling the class.
I said my VMware didn't work well this morning. I had difficulty following the class. That's why I'm not raising my hand.
Okay.
Yes, sir.
So, but do you have the setup?
Yes, I do.
So have you installed it before?
Yes, and it was working fine before. It was this morning.
Okay, so Emmanuel will help you out on that. Just, I know sometimes it happens like that, so I understand. Sometimes it can be very funny, but sincerely, there's always a way out of it. So I think I installed my own VM almost twice or thrice before I got it finally working. So you can meet Emmanuel. Emmanuel will always be of help to you. Okay, Emmanuel, do you want to say something? Emmanuel. Emmanuel.
You asked that you raise their hand if you have the PC, and we have those two people raising their hand. I don't know how this is possible. I don't know how this is possible.
I think they're connected with their phones. You guys are not
raising your hand. Please tell me what I think you are not raising your hand.
I think they're connected with their phones.
And they should stop now.
The phone doesn't have the option for that.
I actually have my virtual machine, so I'm connected my phone, so I can't use my hand actually.
Okay. Olayoju, do you have VM? Richard?
Yeah, sure, I have, but it's not functioning well. That's why this is my hand.
Okay. It's not functioning well. Okay.
Yeah, I didn't shut down properly.
Oh, because you didn't shut down properly. Okay. So, do you have the VM? Is it working?
I don't have.
Why?
I'm not collected my material.
Okay. Marvelous. Do you have?
No, I don't.
Why?
The other time when I came by, I was not with a flash drive to get it, but I will come around this week to get it before probably tomorrow. Get it.
Okay. Ebube, Okoli, do you have?
Same condition with Marvelous.
Okay. Please, because on Friday, starting from either Wednesday, at least either Wednesday or Friday, we'll be starting fully on practical classes. And the methodology of the classes, you do the practical sessions at home. The practical sessions are very simple and well explained. So you just need to give 1 hour to less than 45 minutes. Just run through the practical sessions of each class and you get it. So it's very simple. You don't need an instructor to take you through those practical practical session. So what we are expecting you to do is that before the class on Wednesday, you should have practiced on your own. So in case you have any difficulty running the code, then we'll come to class to fix it. So that's what we are only doing. So we won't be coming to class to take you guys through the practical sessions. No, it's very simple. Anybody can run it. If they say plug this thing, plug it. If they say do this thing, you do it, and it's going to work. They've tested it and it is working. So if only you have difficulties running it, that's where we come to the practical class to tell you how you can fix it, or people in the class share with you their experience on how they fix it. So every week we must make sure we are up to date regarding our practical class. So Friday is just a review session on all the practical session, on all the practical lab work. So if you don't have it, or if it's not working, it's going to be difficult for you to flow with us. And I understand when you are in class and some people are ahead of you, you feel as if you are missing a whole lot. So that you have that feel, please do everything in your best to get those VM issues sorted out. Adetoro, you said you have issues. Please meet up with Emmanuel. He's going to assist you, please. Eputamino, please meet up with Emmanuel. You guys are having issue. It can be solved. Just get through to Emmanuel. He's going to advise you on what to do. So please, we need to go on with the practical class. As much as we are going on we are trying to explain the theoretical class. The practical class is also very important to us because that is where you see what you're doing and you see the beauty of how it works and how you can implement it, and you know how you can tweak one or two things in case of real life implementation. Please let us try. You have your contact person in the house, Emmanuel. Please get in touch with him. Maybe later in the day, it's going to help you. So thank you. So as I was saying, Friday, Wednesday might be for our practical class, so you must be very ready. And I can call on anybody to take us through the practical class because I'm going to assume you have gone through it and you run it on your machine, you share your screen. It's going to be a general class. You share your screen, if I should call on your name, and you are unable to now display. So then we are going to have a score points board whereby you say, okay, you're unable to present your practical class, -5 points. So please, on a lighter note, it's just so that we can all be carried along in this session. So thank you. So as I was saying, these are our objectives for today, and
Sorry for cutting that.
okay.
The DASCA material for engineering, I know it's not the same with analysts, so I'm not sure if we're having the same practical class all through.
Okay. No, okay. We won't be having the same practical class all through. The practical class for analytics is most of the time is mainly analytics, and that is making use of R for the analytics and making use of Power BI, Tableau, and other stuff like that. So they are different. They are absolutely different. So we are not going to make use of the same thing. So that means thank you for bringing that to my notice. So that means the engineering guys, they will be the one leading the practical sessions. So I know those guys on DASCA analysts, you might not have access to the material. So yes, we can pardon you. But those guys on the engineering stream, you must be able to lead us in the practical session. So thank you. I've answered your question.
Yes, sir. Yes, sir. Thank you very much, sir.
All right. So MapReduce is a framework for executing highly parallelizable and distributable algorithm across huge data sets. So let me share a visual with you. So it's part of the resource material on Daska School. And when I was going through the video, I saw that place very interesting, and that will explain that alone explain all the concept of map reduce. So I'm coming. One minute. From this guy. Okay, can you see this? Can you guys see my screen?
Yes, sir.
Yes, okay, thank you. So I would like, in summary, explain the whole concept of map reduce with this concept, with this with what you are seeing on my screen. So like what we have here said, MapReduce is used to run parallelizable and a distributed algorithm across each data set. So when you have each data set, you want to process it, then MapReduce is the best guide for you. Before we go to the visual, it said Hadoop combines data storage and processing. So one interesting thing about Hadoop is we have both the data storage and the processing, like we have on other database too or data warehouse software too. I said Hadoop main process engine is MapReduce. So the real guys that processes the job, like the guy that do the processing, is the MapReduce. He said it integrates existing Hadoop data storage into processing, provide a unique combination of simplicity and power. So I'm going to summarize the whole process so that we can buy a lot of time and can have more time to ask questions. What MapReduce as a processing unit of Hadoop is you have data block on different nodes, and for instance, I'm trying to see. Okay, let's just picture that you have data block on different nodes, and you want to count some numbers. You want to count, say, okay, how many record do you have on a data block on a particular node? You don't need to specify the node. The moment you run the MapReduce function distributes itself on all the nodes. Hello, Emmanuel.
Check our chat. Check our chat.
What do you say?
Just put the date on just put the date.
Emmanuel. Sorry, 1 minute. Let me just. Okay. Okay. So when you have a MapReduce function or a MapReduce job, it's going to distribute itself across different nodes. Just 1 minute. Okay, so you have the MapReduce function distributed across all nodes, and that will make the job very easy. So the ability for a MapReduce to distribute itself, that is one of the advantage of a MapReduce function, MapReduce job on the Hadoop ecosystem. So going to our visuals. Yes, there's 6 components of a MapReduce, like the whole MapReduce from start to finish. There's what we call the input space. So this is where we have the input space, like, okay, what is the input of, what are you passing into a MapReduce job? So at least you have an input, and the input is like a data block. A data block is like a part of a table. So if it is a transactional table, it's a part. Maybe the data block is just like the first, the data block on a data node can be the first 50 transaction. On the second node can be the next 50. On the third node can be the next 50. So a data block is blocks of data in different nodes, and each block has transactions in them, and they are independent. Like you only replicate data blocks, you don't replicate transaction. So those transactions are unique, so they don't repeat transactions like reuse transaction in this data block. So that is what MapReduce taking as input. So the next thing is the splitting. So now to each splitting, there's what we call the key and the value. Now, how does this key work? What is key? What is the value? Now, a key is just like to one, like picking the first line, like this H base, pick and OZ, they are like the first transaction. So that is a record. The second transaction is IVE, and OZ. The third one is H base, IVE, and P. So each line is what we call the transaction. So the combination of these three is what we call a block. So that's how a block really looks like. So in a block, you have series of transactions. So if it's a transaction table, so if it is a text file, you're going to have the document, and you're going to have the line separate. So this is so far this is a transaction table. What separates each transaction from another is the transaction separator. So that means inserting it into the entry into different line. And likewise, in text document, you have line separator and say, okay, do you know, maybe in program you see something like /n. That's to tell you, okay, this starting a new line. So likewise, it's happening here. So the case study of this is a transaction table, and each line is a transaction record. So maybe H base is the name of a column, or H base is a response to a column. P, IVE, and IVE is a response to another column, and Z is another response to another column. So that's the input. Now on the splitting parts, now, so the first key, maybe for the first entry, H base OZ, the key will be like, say, okay, 0, and the value will be this whole transaction, H base, P, and OZ. So that is the value, and the key is 0. Now, the key for IVE for the second transaction will be, so it's going to count. So if this one is 0, the next one will be, the number of record here is 1, 2, 3, 4, say 1, 2, 3, 4, 5. Also counting this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Something like that. You're going to have like the key value here, because it counts, the key counts character. So you're going to say, okay, for key 13, the value is what we have here, and it's going to continue. It's going to count how many characters we have here. Say maybe the key is now 28, and the value will be this. So it's just like counting how many records we have per line and assigning the value to it. So we are going to have a key and a value. So that's going to help us. That's going to help the process to decide and say, okay, this is a separate line, and this is the length of the separate line. So when the process is working on those lines, it says, okay, this is what I'm doing. This is what I'm doing. So the next thing is, if you understand the first splitting is splitting by rows. But when you are trying to map, the mapping is counting a particular string. So you are going to say, okay, please help me count how many words do I have in a particular value. So what this guy is doing is, okay, all these values, say h base 1, is splitting all the words and say, okay, h base appeared once, 1, and even if it appears twice, it's still going to put h base 1. So that is what the mapping is doing. So you are mapping each character to a particular string to a particular value called 1. And most of the time it is always 1 when you are trying to map a function. And the interesting part is when we are now moving into shuffling, the shuffling is now going to pick what looks like we have h base here, we have h base here. Okay, bring them together. So that's why you see this is now having key value and list of value. So now the key value for this guy is h base, and the list of value is 1 and 1. Are you getting me? So you see key value 2 and list of value. So the key value here is h base and the list of value is 1 1. The key value here is I, and the list is 1 1 1, and so on and so forth. So that shovels and arrange it. And on the reducing part, okay, now let's reduce it. So that's what we call the mapping and the reducing. So the reducing is, okay, if you are doing the sum, say, okay, I want to count how many h base appears in my transaction table or in my record, then the reduce, just write a function. So the reducing part takes the key value and aggregating function. So that's very interesting. It takes the key value and say, okay, now let's aggregate it, and it does the aggregation. So that's that. So you see, and the reducing function, the output of the reducing function will be the key and the corresponding aggregated value. So and we have your final result, all of them stack together. So like I'm saying, from input to shuffling, all of them happens on different nodes. So all the nodes present something like input to shuffling, like give us the shuffling part. And the reducing function now aggregate them together. So maybe node 1 gave me this and node 2 gave something different. The reduce will now aggregate everything together. It's going to reduce it and say, okay, what node 1 gave me, what node 2 gave me, oh yeah, come, let's talk and let's have it together. So to me, I even feel it's convenient for us to see that the reducing function starts from the shuffling, because this is when you are picking like terms together. Say when you are solving arithmetic operations, okay, collecting like terms. So that's what shuffling does. So and that shuffling can run on multiple nodes, collecting like terms and passing that result, the like terms collected, into the reduce function. Then reduce gather all the results from the shuffle guys and give us the result and say, okay, in the whole document you passed in across different nodes, this is the statistics of what documents you are having. So this whole process tells us how the map reduce architecture works. You have a question before we continue?
Yes, sir. I do have a question.
Okay.
Now, can you go back to the chat with
To the visuals, right?
Yeah, the visuals. Yeah.
Okay.
Fine. It's very beautiful, and with the way you really broken down. Like I enjoyed the explanation from beginning to top to bottom. It's really really nice. What I wanted to ask is, in a case like this now, how can we tell how many nodes can we tell how many nodes by just viewing this? Can we say there are only 3 nodes? And if there are only 3 nodes, why are we having 4 different results out? Like, do they match, or I don't know? I'm trying to connect the number of nodes with regards the number of operations being executed, because it was 3 from splitting and mapping, and then from shuffling to reducing, it went all today to 4. So I'm trying to understand, is there what exactly that implies when it comes to attaching to number of nodes and all of that, basically.
Okay, thank you. This process happens. This is just a case study of what happens on one node. So this same process happens on the n number of nodes you are having. So this map, the map reduce function. So when you execute a map reduce job, the script, like the job, goes to each of the node to perform all these operations in parallel. So this is just a case study of what happens in a particular node. So all these guys, the entire process is happening on a particular node. And if you're having 10 nodes, this process is happening on the 10 nodes in parallel. And they are not going to affect each other because they have different data blocks. So, and to the question you asked, so we have from transaction. So what this map reduce function is just doing is that, okay, count how many H base do we have in my data block. Count for me. Maybe this the input is a Word document, and we have like 3 lines. Okay, count for me how many H base do I. The objective of the map reduce function is that count how many H base you have for me on the data block you have on this node. Count how many hive, count how many peak, and count how many OZ. So that is the objective of this. So
Okay,
and
so
this
sorry. Hello? Yeah, I
hi.
understood the objective. I understood that part. I was just wanted to know if it was affected by the node, but you've answered that by saying this is a case study from a particular node. So different nodes could
Yes.
have their different input, but this is how the configuration or the model works, from input to splitting to mapping all the way down to final results. And it's
Yep.
clear now. Thank you very much.
All right. Thank you. Thank you. Thank you. Thank you. Okay. So
Sorry. Hello.
and hi.
I'm sorry. I still have some problems understanding. I want to know where exactly you have nodes in this. So from this basic flow, what exactly is the node that is doing any operation here? I don't really get the node concept yet. So I don't know if you can just pinpoint. Just let me know, okay, how I can select, how I can pinpoint the node if I see a flow like this or something.
Okay. I want to ask you a question.
Okay, I'm with you.
So I want to ask you a question. What do you understand by the term node? When they say, okay, a data node, what is the mental picture you have in mind?
A node, okay, I think it should be a place where data is kept or something. Data is analyzed, or yeah, that's what I think. In the place where some data is kept and analyzed or something.
Okay, so that's fine. So like you said, a node is a place whereby, okay, it's just like a machine. So a node is a machine, is a server that processes that helps the Hadoop process. For instance, now, if I'm the name node and you guys, all of you are independent, and I'm having a job and I send to you guys to do, and all of you does the job independently. All of you guys are node. You are system. You carry the same property as a name node. So, but this guy, this whole process, it's just as if I'm giving each of you the same task to run. So we are running all these tasks on a node. That means this circle runs on individual machine. A node is a machine, and all this process run on individual machines, but they run it in parallel. So this is a process running on a node. I think that's the best answer I can give for now. So all this process runs on a node, runs on a machine. Computation. This is just a flow of what happens on a particular machine. Are you getting me?
Okay, so everything here, all what is in this diagram, from the input to the final result, is happening on just one node.
Yes.
Oh, okay.
Okay. Let me make it clearer.
Okay.
From input to shuffling happens on a particular node. But the reduce, it can come in, it can be dynamic. I'm coming. I want to check a document for you guys. Oh, 1 minute. Sorry, I don't find the document. I will have referred you to the page where we have the best diagram that explains how a node work. Okay, I think I've seen it so that we can. I think it's just a revision of what happens on a map reduced system. Give me 1 minute. Okay, so if you're having the material, page 48, and you have a diagram. So from the diagram, we discovered that okay, the entire up to the final result, we have it on one single node. Are you getting me?
Sorry, please,
Yes, I am.
Are you guys on page 48 of your handbook?
Yes.
Yes.
Yes. Okay. So do you see the diagram there?
Yes.
So the diagram you have there is what we call. You see what we call the input data and job code. So the job code is a map reduced job, and the input data is like the input you have here. So from splitting, mapping, shuffling, reduce, and the final result is like the job code. So each of the nodes gets same map reduce function, and they act on it. You see to server 1, and you see what they call job code 1 plus process data. So they process it, and the result, the final result, it's aggregated. So the reduce, I will say, all of them submit the shuffling to the reduce to produce the final result, and the final result is sent back to the reduce software so that the client can view it. So the job code is like the map reduce job, and this answers the server process and the input data. So that we don't buy much into our time. Okay, and that is that. So from the visual, from what I showed you now, said Hadoop combines data and storage, data storage and processing. The processing is the map reduce functions and the likes. So except for a developer, map reduce will be a key tool to process big data. So especially to the big data engineering guys. So to process your data, you need a map reduce function. Okay, like what I explained in the visuals. In the first map we have the key and the value. So the key is like, to a particular, in the mapping session, the key is like, as I said earlier, the key is just like index given to each row. So, okay, row 1, row 2, row 3, row 4, row 5, something like that. And the corresponding value is the total length of the values you have there, and you see the sort and you see the reduce. So this is just explaining what I said earlier. Said the MapReduce framework sort a mapper output and combine each unique key with all its values. Okay, a mapper and a reducer together constitute a single Hadoop job. So when they talk about Hadoop job, it's a mapper and a reducer. So there's another part when you're building the script. There's another part you call the driver. That's where you specify the configuration, the input and the output. We'll get to that, especially when we get to our practical class and other materials and other topics we're going to discuss. A mapper is a mandatory part of a job. So a mapper is a part of the job that you use to select, especially the column you need. So the mapper, even if you are not aggregating, at least you need to select. So it is very mandatory. So it's like the select statement. So when you write a select statement, you can say select cost ID, account number, age from a particular table. But a reducer is a guy that says, okay, sum. So when you have any aggregation function, that's a reducer. So a reducer works most of the time on aggregated functions like count, sum, average, and the likes, and even it can work on algorithms. Especially these guys, reduce mapper. A mapper can be a function that picks inputs, let's say a pictorial, an image input, and runs an algorithm on it. So a mapper is mandatory part of the job. So a reducer is not always needed. If there's need, you get it. But if there's no need, you just leave it like that. If you have nothing to reduce. A reducer is an optional part of a job and can produce 0 or more keys value pair. Okay. The main component of MapReduce executions. So we have the driver, the bigger boy. So the driver is the guy that connects, that manage the input, output, the mapper, the reduce, and the configuration. We have the context. So we have available at any point of reduce execution. It provides a convenient mechanism for exchanging required system and job wide information. So in context of what? So we'll see that. So I will try play a video for you because you guys don't have access to the data school now. So I will play a 16-minute video for you so that you can get a first-hand explanation on how the concept works. I think I can still afford to play. This is a 26 minutes video. You are going to see it to understand the concept better. So when you have any questions, then I can answer. So on we have the input data and we have the input format. So you are going to see all these when you see the video. So and we have the input split. It defines a unit of work for a single map task. We have the output format. So sometimes you can say, okay, my output format is string, is text, and you see that when we are trying to go through the video, and some other parameters that we'll be considering. You understand what they call the partitioning, the shuffle. I think we can see the shuffle somewhere here. So this is the shuffling. So how the shuffle really works. So you have the record writer, the guys that writes the record. You see the source. Those are attributes, and you see how the process really works. So the process is at the center of the whole engine. With the process, you specify your mapper, your reducer, the input, and the output. So, and these guys goes from input splits and to each of the data block. So like we said something about splitting. So so that I'll be flipping. So you see the input split here, it's the same as what we have here. So you split by row. So what this guy does here is, okay, we are splitting each record by rows and use the mapper on each record and get the output, and everything is shuffled. You see, you can have all these guys, all these input splits, they are on different, say, data block, and at the point of shuffling, all of them comes together. You see, partition, shuffle, and sort. So at the point of partitioning and shuffling, from different node, all of them comes together to feed into the reduced functions, and you get our output well defined. So you see, we define the output format, and it's going to force the output format to meet a particular requirement. If the output is a float format, or is it double writable, is it text, that guy is going to force it to that data structure. So, okay, so I would like to make us understand this part. So, we said the framework provides the following support and application development, scheduling. So, scheduling. So, one thing I would have saved me a lot on the project I'm currently working on is what we call scheduling. Scheduling is just a process. You say, okay, at this particular time, do this, and the system on its own does that. So do you know all these? When you get alerts, it is a scheduled process. The scheduled process is just put on a trigger and say, okay, if this guy gets any credit alert, then send out a text message. So it's just a trigger and it is scheduled. And sometimes we have scheduled like say, okay, there are processes I've scheduled for say run every day by 11:55. So every day the process run. I have a process that I schedule. I say, okay, run every day. Send me a mail by 12:45 a.m. Even if I'm sleeping, the mail comes in. And sometimes I might be awake and just get the mail. That's the scheduling is something that helps in automating a job. And even when you're not there, it's gonna work. So synchronization. So okay, there's something about scheduling. It said another aspect of scheduling is speculative execution, which is an optimization that is implemented by MapReduce. So this is in line with what we call the error and fault handling. So when a job fails, it restarts it. You see, so accomplish job execution in the environment where errors and faults are the norm. The job tracker attempt to restart failed task execution. So when the job is scheduled and there's failed task, it reinitiates it. So there's what we call the job tracker. The job tracker output is always okay if there's a success or failure. So if the job tracker sees that okay, this is a failure, it will restart the job to make sure that okay, the process runs and the result is gotten. So you can set this to be either on or off. Say okay, anytime a job fails, please restart. So okay, let's go to the video. So I would like us to just see. Okay. Okay, this explaining. Okay, let's see from here. Are we good to go?
Yes, we're good to go.
We are good to go. Okay. So please, in case you have any question, in case you discover that anything is not clear to you, please do well to call me back and I will explain. Thank you. Sorry, let me.
Hello, Saidi. Saidi. Hello, Saidi. Can you hear me?
Yes.
So, are you playing the video already?
Yes. Are you seeing it?
I'm seeing it, but I'm not hearing anything.
Wow, 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 wow. I was thinking you guys are hearing. So if you can't hear it, so there's no need for me to play it then.
So if you want to play video, or want to play anything that has audio, you have to reshare your screen, then include audio.
I'll do what?
You have to reshare your screen, then include system audio.
Okay. Okay, let me try it then. Sorry. So Emmanuel, so I should click share again, right?
Yes.
So I
And
want
you
to
see
share.
another.
Okay, include system
Well,
audio. Thank you.
exactly.
Thank you. Thank you. Thank you. Thank you. Thank you.
Phases. In the map phase,
Can we
we
all hear now?
typically identify
Emmanuel, are you hearing
what
now?
Yes,
data
sir.
to
Yes,
be
sir.
read from a
Okay.
record. Every record goes through the map phase. And in the reduce phase, we typically do aggregation of the data which is processed parallelly. I have navigated to the browse file system because I wanted to show to you how we do the mapping phase and the reducing phase at a very high level. So let me navigate to browse the file system, which will take me to the file that I will be showing in the analysis a couple of minutes from now. So the data that I'm going to use over here is a data file that's called as transaction. So if you look at this particular data file, you see that there are multiple values in different columns. There are totally 9 distinct columns in this particular data set. We have got a transaction number followed by the date, followed by the customer ID, the amount of the transaction, the primary product of the transaction, the secondary product of the category of the transaction, the city, the state, and whether the transaction was via cash or credit. So if we have to identify the sum of all the products belonging to a subcategory, how would we go about doing it? So in the mapping phase, you will identify what you want to pick from a record. The record by default would be a new line. So the complete record would be processed by the mapper. In the mapper, you will pick up the relevant columns that we want that I just explained some time back. So we will be picking up the amount and we will be picking up the cardio machine accessories from the first record, and in the similar way we will be picking up the different cut amount values because they are all going to be there at the 0, 1, 2 and the third column, and the fourth and the fifth column is what would be the subcategory that we are interested in. So this is what would happen at the mapping phase. In the reducing phase, all the values that relate to a particular product, in this example, weightlifting gloves, would simply be aggregated and the map reduce function will show us the sum of amount for a particular subcategory. Where Hadoop gives us the ability to store really huge volumes of data in the form of bytes and exabytes in different multiple systems in form of blocks. It is MapReduce which gives us the ability and the framework and the implementation pattern to process this huge volume of data in a parallel and reliable fashion. Please note everything in MapReduce would be a key value pair. So the input to every phase, the map phase, the reduce phase would be a key value pair. And the output from both the phases will also be a key value pair. It could be a scalar key, that's a single key, or it could be a composite key, or for that matter, value also. So each node where the data is distributed would be running a mapper and would work on the data that is lit on that particular node. And that is how parallelism is achieved. A quick summary of the benefits of MapReduce programming would be one, it abstracts and allows us to handle the input-output limitations that we primarily have in computing, whereas the size of the disk and the storage has increased, the input-output has still remained the same. The second benefit of MapReduce would be the share nothing architecture, where each of the node would process the data on that particular node parallelly. There is no primary information on one node by which it will be able to identify what the other node is doing. The other beauty of MapReduce programming is how it handles the various processing failures that might be as a result of the hardware failures. And it does in a transparent way so that the end user is not aware of the fact that one of the nodes where the processing has happened has failed for whatsoever reason, but the framework will ensure that it will start the task on another node where the replicated block is. The other benefit of MapReduce programming is the concept of data locality, where the code goes to the data and the processing happens at the place where the data is located. There is no movement of data involved in MapReduce programming. And the last but most important aspect of MapReduce programming is the way how it abstracts the distributed layering from the developers. When we are writing a MapReduce code, we don't have to take into consideration the fact that the data is spread across multiple nodes. We don't have to write multi-threaded programming, but in fact write as if the data is there on one node. It is a framework which ensures that the code goes down to the data on different nodes and the processing happens parallelly and in a seamless fashion. So in the second section, we are going to see a basic MapReduce flow with some sample dataset. There are typically 6 individual distinct phases that we have in MapReduce. We have the input phase where the blocks would be read by the mapper. Then we have got the splitting phase where from the block, based on the record, the individual mapper would pass every record to the map function. So identification of the record is very crucial here. So every record is split. There are various input formats we have which does this actual splitting. Then we have the map phase where the business logic of the mapper comes into picture. Then comes the secret background work of the shuffling phase where the data that is outputted by the mapper on multiple nodes are brought together, they're shuffled and sorted and handed over to the reducer. In the reducing phase, do the final aggregation work and the result is stored back into HDFS. So these are the distinct columns that we have in a MapReduce process.
So to take an example.
Hello. Hello. Okay.
Hello, sir.
Do you have any questions so far before we continue?
On this
What do you say?
I have a question, sir.
All right, ma.
Okay.
I'd like to reference the knowledge check we we discussed in the last class when you asked them. I think you asked someone the question and then you were saying pick a friend or call a friend. Okay, so what I understood from that explanation you gave that day was that replication occurs the across the data nodes, the different data nodes. But today, for today's class now, I'm saying that it's not just replication, so that the processes are also replicated. Is that it, or am I getting anything wrong? The last time, I think maybe I misunderstood you that the blocks are only replicated, but no process occurs in the other data nodes.
Okay, I can recall the question. The question is this. The question was that, okay, if a particular process is running on a block on node 1, would the same process be running, like if node 1 is processing block 1 and block 2 and node 2 also has block 1, would node 2 also be processing block 1? Should we go there? So the question that there was, I want to reiterate so that I can get the question, so that we can get the question and justify the answer, so that we can get a grasp understanding. If data on different nodes are replicated, but processes only run on one block at a time, though processes on different nodes run in parallel, but they run on different nodes, two nodes cannot be running process for one data block. Please permit me to go back there so that we can just, because sincerely I know that understanding concept is very, very important, very, very important, very, very. I'm coming, I'm here to get that. Okay, I want to reshare my screen so that you can see the question again, and so that we can discuss it and justify. So are you seeing my screen? So this is the question. So this is the question that was asked, right? Is this the question you are referring to?
Yes, sir.
Okay.
It is.
So now I want to join this question to what we just had. There's a noise coming. Since the data is replicated thrice in HDFS, different node replicates a particular block. Does this mean that any calculation done on one node will also be replicated on the other two replicated files? So this is just talking about files. It's not talking about running processes in parallel. The parallel processes runs on different data block, not on the same data block. So in this case, you only work on one data block at a time, but other processes running on other nodes are running different, their inputs are different. So the input for data node 1 is different from inputs from data node 2 and inputs from data node 3. Though the processes are running in parallel, but they are running on independent data block. So that is connecting this to what we just heard from the video. Is this clear?
Okay, so if each data node is running its own process, does replication still come in here?
Okay.
Like, I don't know if you get my question.
Okay, let's relax our mind and let us make it too technical, and so that we'll go to abstract. Okay. If I am the master node and I'm telling the 10 guys on this team, I say, okay, I want to count how many bees I have in a bag of how many rice seed I'm having in a bag of rice. The word I'm using, count, is like the map reduce function. But let me say, the first thing I did is that, okay, let me distribute a bag of rice across 10 people. That is data sharing. So that means I'm sharing data into different nodes, right? But the issue here is that I can share a particular portion, though the example I'm giving it is not tally, because you are going to assume when you share to Mr. A, you can't share to Mr. B. The same quantity you share to Mr. A, you can't share the same quantity with Mr. B. So we are going to assume that, okay, they are independent. But in HDFS, the same data set that you share to node 1, you still have a replicated copy on 2 other nodes. So after they share the data, it is shared. There is now an instruction from MapReduce, and the MapReduce say count the number of grain inside a cup of rice. So count the number of record inside the data I've given you guys. That command goes to all the nodes in parallel. All of them hears that information, and they all start working. But the issue is that they work on independent data sets or independent block nodes, such that no 2 nodes will be working on the same data block. So the YARN process makes sure that node 1 is working on a particular data block that node 2 is not working on. Though all of them are working in parallel, but they are working independently on different data block. Though they have access to other data block, but there is a service that is on that will tell them, see, node 1, oh, just work on data block 2. Node 2, just work on data block 3. Node 3, just works on data block 1. So there's a process in the architecture that tells each node which data block to work on, and the moment you communicate the process, the MapReduce job to them, all of them picks the MapReduce job and work on them in isolation. Then the reduce gathers it and push it to the output. So that's that.
Well understood, sir. Thank you very much.
You're welcome. Okay, now, sorry, I want to reshare my. So we start from here. Please, in case you have any question, please, you can stop me, because see, if we understand, maybe when I was in school, I make sure I understand 80% in class, because I'm not a good reader, but I like understanding once. Please ask me question. If you can get it now, even when you get to the exam, you can easily figure out the odd answer because you understand the concepts. Okay. So I want to be sure. Okay.
If we have a block in which we have that we have in a MapReduce process. So to take an example, if we have a block in which we have got 3 records, and in the first record we will have words like edge, base, peg, Uzi. In the second record we will have hive, Uzi, and in the third record we will have edge, base, hive, and we have got multiple blocks also spreading across multiple nodes. If that is the sample use case that we have, let's see how does the map reduce word count process would happen on a single block. So the splitting phase would be done parallelly on all the nodes where the blocks are present. And by default, new line is what is considered as a split in the case of text files. So if you look at the first record, the key that is given would be the cursor position and the value would be the whole record that we have. So if you look at the first record, the key is going to be 0 and the value is going to be the whole record. Now, the way how the cursor position is calculated is it goes from left to right and it'll keep on incrementing with the number of spaces, and for every new line, that new record, one would already be added to the key. So if you look at the first record, it was 0, HBase, Pig, and Uzi. If you look at the key for the second record, the way how it will do is it'll count the number of characters, including spaces. So since key was 0, then it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Plus 1, 16. So for the second record, it will be 16, hive, hive, and Uzi. 16 is the key, and hive, hive, Uzi would be the value. It would calculate the counter again, like how I had mentioned earlier. So it will be 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. And it will be 32 for the third record, that is going to be space, hive, and peg. So this is the way how keys and values are determined in a particular block. Please note this splitting phase will be running across all the blocks wherever the data is present. So your key and value is what will go down to the mapper. The output of the mapper would always be a list of keys and values, and let's call it as K2 and V2. So what do we do in the mapper is the business logic of what I want from a record and how do I want to process it. And now since we are talking about word count over here, what we would do is we would typically break that value that was HBase, Pig, and Uzi for the first record. Based on spaces, I will use string tokenizer class to split up the words, and for every word, I will suffix 1 to it. So for the first record, the map output would be HBase, 1, and Uzi, 1. The output of the mapper is written in the node wherever the processing is happening. Please note, it is not there in HDFS. It will be written in the local node wherever the processing is happening. And after the job gets completed, this local directory would be removed. Similarly, for the second record, I would have hive, 1, hive, 1, and Uzi, 1. Please note, by default, we are not talking about any optimization over here. And yes, in the second record, hive is repeated 2 times. So it would definitely be better if it was hive 2. And that is what is typically done in another phase that is called as the combiner phase, what we will be talking about at a later stage. And in the third phase, that is the third record, I would have HBase 1, hive 1, and pig 1. After the mapping phase is completed is where the magical process of the shuffling happens. What does the shuffler do is it will bring together all the values of the similar keys across multiple nodes to an individual reducer so that the aggregation can happen. So you can see over here the way how all the different values would be shown. So all the values for pig is brought together. All the values of HBase is brought together. All the values for hive and all the values for Uzi is brought together. So you see that although this was generated by different records, the shuffling will ensure that the values for a key is brought together. And that is what is passed on to the reducing function. So the input to the reducer would be a key and a list of values. And you would see here how it would go ahead and do the aggregation. In the reducing phase, typically aggregation would be done, and you would see that for edge base, it gives me the aggregated value as to for high it will give me 3, for Uzi it will give me 2, and for Pig it will give me 2. And the aggregated results is what is written into HDFS. So the final output, what you see in the Hadoop distributed file system, which is the result of a job of a map reduce analysis, would be a list of K3 and V3, which is a set of keys and values. So you would see that the final output would be coming as HBase to Hive 3, Uzi, and Pig, and you would see that this is sorted in a lexicographic fashion. So this was a quick walkthrough of the way how MapReduce is done across the 6 phases and how does it process. And we have given that with a sample data so that you would know how it navigates between the 6 distinct columns that we have in a MapReduce process. Having seen the MapReduce process in the third phase.
Okay. Do we have any question on this guy? I think you were able to understand clearly what I explained, and I think the guy did better justice to it. Do you have any question before we move on? Okay. No, for now. Okay.
6 phases and how does it process the execution. So we will show you how to execute.
Okay, so the next section is very interesting, and you'll be seeing. So this is it's just a view of what you see in your practical class, and it's just a view of as soon as you have your visual machine installed, you can try out the practical session you're about to see. Okay, and in case you have any question, so I don't think there should be any question. There should be a question in the practical sessions, but in case you have anyone, let me know.
A MapReduce program which has been pre-written, and the purpose of this program is to show you the sum of transactions that we have in our TXNS dataset. So we will go ahead and perform the execution on the TXNS dataset. So let me navigate to the name nodes status page on the browser and browse the file system, and we already have the transaction dataset loaded into HDFS. The size of the file is 84 MB, so there will be 2 blocks of processing what would happen. And I already have got the code written. So since this is an execution process, we will go ahead and show the execution of this particular code. I have already exported this particular code. I have already exported the jar file from the Java code, and let me move on and show you the jar file. So if we go down to the home directory, I have kept the jar files inside the Archive folder. So if I navigate down, you would see that I have got a jar file called as transaction analysis.jar that has already been created. I am going to run the MapReduce process on this transaction example. So let me go to the terminal window. And let me navigate to the Apache folder where I have got the transaction analysis.jar file. So to execute a program in the console for a MapReduce would be to say Hadoop jar, the name of the jar file, that is transaction analysis.jar, the name of the package, that is com.wiley.some driver is the name of the package. So every MapReduce program would have a map code, a reducer code, and an entry point code called as driver. So here I have named it as some driver. Then comes the parameter of that particular Java code, that is the input file. And I want to give the output file, that is some transactions. And let me execute this particular jar file. So upon submitting this particular jar file, it will go down to the cluster. You see here how the total input path to the process is kept as one because I've got one file. It will show me what is the job ID that I'm having, and then it will start with the MapReduce process. Let the MapReduce process run. In the meantime, let's go ahead and see what else do we have.
Okay. So that is just that we're going to understand it better in a more practical class when we have a hands-on experience on how we write our first MapReduce job. So you understand how the map function looks like, how the reduce function looks like. I want to see if I can share another document with us. There's a document, there's a visuals that also explain the MapReduce so that we can understand, okay, if I want to write my own MapReduce function, how do I go about it? And so because most of the time in my own curiosity, I don't like people doing things for me. I'm like, okay, let me do this thing for myself. If I want to do it for myself, how do I go about it? And okay, I will share a document. I want to see. Okay, I'll just share this screen with you. Okay. Hello? Oh, okay, you can see my screen. Okay, so another thing, because in my own personal belief, I am practical driven, and as much as we understand the concept, I want to see. I know most of us have written a lot of codes, and at least we should understand the basic of the code we're writing. And when you're saying mapper and reducer, what does it mean and how does it move? So what's happening? So this is an example of a simple mapper and reducer function. So he said, okay, the method. So you have a document ID from a document. So this will be key, and this is the value. So from for all mathematical expression for all elements in B. So for all term in document D, what do? Give us the term. So for all documents here, give us the term and put count equals 1. So it's going to be, so this is like the mapper function that you see that, okay, you have a key and a value, and it is close to the value you see when you have H base 1, pig 1, Jose 1, and the like. So see, this count is static. You say, okay, just give me, we are just counting, we are just, at least we are listing, we are, okay, say that's after splitting, we are trying to split and say, okay, this is 1, and we are getting things done so that we can have a list. So after this guy, we have the shuffling to shuffle together those guys that have the same term in common, and you have the reducer. So what this reducer is doing now is like the normal Python code you always write when you set a particular variable to 0 and you do a loop. So this is just a loop function, like the normal thing we are used to in our normal programming. Say, okay, sum. So sum for all counts. So the input of the reducer is a list of values and a particular term. So this is coming from our shuffling. So you know, in our shuffling example, we have a text, we have the key and list of values, which is a 1 1 1 1. Maybe the key is H base and we have list of values 1 1 1 1. And we want to try in this case to sum up all the ones. So if we have H base appearing twice, by the time we sum up all the ones, we now have H base equals 2, and the output is term and count of the sum. So this is a very simple of a mapper and a reducer function, so that you can see what goes at the back end of we saying a mapper, a map reduce function. Okay, I would. Okay, so let's go through. Let's go back to our slide and see a few things we can just summarize before we call it a day. Okay, so in our map reduce, like we said, we have the shuffling phase. I think we can get this from the last video we watched when we talked about the inputs, the splitting, the mapper, the shuffling, the reducer, and the final result. We have like 6 phases. So part of the shuffling is just selecting, collecting like said. In the shuffle phase, the mapper output are sorted and distributed to the same reducer. This process is in MapReduce 2 is similar to what it was in MapReduce 1. Said, however, in Outlook 2, the map output are fetched by auxiliary EN services called Shuffle and the likes. So we can read up all these guys on our materials, on our doc, on the material given unto us. In case we have any questions, sincerely, always open. He said, moving from MapReduce version 1 to MapReduce version 2, so, and which is the ability to do what we call the access point, like API backend capability. So what we have said, MapReduce code that uses the earlier MapReduce API is binary compatible. This means that the MapReduce bit code will run as in on YARN. Hence, so no recompilation of code is required. However, in case of new MapReduce API, some classes such as job context, task attempt, counter have changed, and hence some API features have been affected. So when you see the new MapReduce function now, currently now we are, as this course is concerned, we are working with MapReduce version 2. So whereby we have a lot of parameters that comes with our MapReduce function, starting from the job ID to the map counter. It's going to tell you the number of records. We're going to have things like the job context and the task attempt context. So like for instance now, task attempt context would be like, is the job successful or fail? So a lot of stuff has been added to MapReduce version 2, which we are currently using. So we'll be talking more about version 1. So in case you are coding using the new MapReduce, you have input output format. So they are just explaining what we have. You can read up for this. So also I'm trying to see. So using Eclipse to developing Hadoop code is straightforward. By next class or latest on Monday, on Friday, unfailingly, I'm expecting all of us should have at least try running our first MapReduce job. It's simple. So on the files that was shared, the code for the process is already there. So you already have the code. The code, you just need to navigate to the code, copy the code and paste it. You don't need to type. So copy, you have a document that contains all the code you'll be typing that you should have typed. They've typed this for you. So just copy it and paste it and just follow it. And let's do our first MapReduce job. So I record that. So you can even pick a document. They gave an example, let's say a text document to act on. That is the word counter MapReduce job. You can decide to just pick any document. It's not necessary you make use of the document they gave you. Just pick a document you feel like, okay, let me run a MapReduce job on this document. Okay, I want to count the frequency of a particular word so I can understand the context at which this document is talking about. So you can just pick maybe a journal and as a text file, you pass it into your MapReduce function and you see how it's going to work. You see the output and how interesting it can be. So I think it's very interesting and very simple to work with. So when you are using Eclipse, so you during the practical class, you'll be seeing how you create your mapper functions, your mapper class, your reducer class, and the main job, and how you compile it, how you move it to HDFS folder, how you execute it. I think the last video was telling us how you execute. When you say hadoop.jar, the name of the jar file, the package name, those are the inputs for executing Hadoop. We have Hadoop jar. You have the jar file that you want to pass in. You have the package inside the jar file that you're extracting, and you also have the input that you are calling, and you're also going to state your output. So all these things you are going to see them in your practical class. Please and please, please and please. These things are simple. Just take time to go through the practical class. Please, if you are still having issues with your installation, please get back to me. Get back to me. Emmanuel is there for you anytime, 24 hours a day, even at midnight. Just beep Emmanuel. He's always there. Emmanuel, am I true? Am I saying your mind?
Wait, that's problem.
What do you say?
I'm not saying anything. I'm not saying. I'm there for them. I'm there for them.
You are there for them. Okay, that's fine.
I'm like ATM machine that is working 24/7.
Okay, so you have all your questions answered by Emmanuel, so it's there for you guys. So you understand this better. So you understand the use of Eclipse and some other things I'm working with. So designing MapReduce implementation, like what we've been saying, is MapReduce is a general purpose and parallel execution. These are just extracts from the video we just watched and said, okay, said to develop successful MapReduce program, developers have to answer the following questions. How do you break up a large problem into smaller tasks? So which key value pairs can you use as input output? How do you bring together all the data required for calculations? So these are to the data engineering guys. So this is how you understand some technical things, and some things it is not trivial. You just need to think outside the box. And sometimes I will say you need to think without the box. If you are still saying, okay, you think outside the box, okay, you are still trying. But there are some problems, there are some challenges. You just imagine there's no box. Just open your mind and think. So let us discuss, okay, some implementation, though we've gone through this. he said, okay, let us consider some example of application of MapReduce techniques in parallel processing environments. So talking about a face recognition algorithm implementation that takes an image, recognizes a set of desired features, and produce a set of recognition results. So image can be your input for your MapReduce function. So that is the beauty thing about big data and the Hadoop. So like I know I think I just jumped into the class where Abisola was talking about the structured, the unstructured data and semi-structured. So when you have images, they are not structured. When you have voice, they are not structured, but those are inputs that MapReduce can work on. So that is the big data itself. Then assuming that it's necessary to run a face recognition of millions of pictures, a set of inputs, image, and a set of outputs, image list. It can be image ID or list of recognized features. So that means that will be running on, let's say, machine learning algorithms. So additionally, a set of recognizing features must be distributed to all the mappers, things like that. So that is that. I think all these are just trying to explain what we've been saying since morning. So we've talked about mappers, we've talked about the shuffle, we've talked about the reducer, we've talked about the results. So that's fine. Okay, question, knowledge check. So how can the parallel process be implemented in a face recognition example using a map reduce as a framework? Okay, so I think I just mentioned that the inputs for an image processing, image recognition is image. So, and one beautiful thing about MapReduce is that your input can be a folder. So it's not necessarily your input is just a file. So you can have, I remember if you want to say, if you want to load file into Oracle, you can either load one file at a time or you just specify load all the files at a time. So likewise in MapReduce, you can work on folder. So this guy will be, the input of this model will be acting on a folder with lots of images that will be passed into the mapper function. So, and on the mapper function, what the mapper function will be working on across all is that, okay, for this particular image, extract feature, so, and the outputs will be stored. So, we said reduce parts of a map reduce is optional. So in this case now you can decide not to have the reduce part and say, okay, you want to get the mapper function and you map a particular image and you extract features. So now features you can extract from images is that, okay, what is the angle of the facial elevation? So where is the guy facing, left or right? Okay, is the person a male or a female? Is the object, what are the objects to be identified in the images? These like those are features that a MapReduce job can also extract for you and keep the results on your HDFS environment. So okay, so building joins and MapReduce. So now what do we call joins? I said two implementation exists for joining data in MapReduce. We have what we call the reduce side join and what we call the map side join. Okay, so we are going to understand this very soon. While implementing a join, all data sets are processed by mapper. That's what we are used to. That emits a join. That is key as the intermediate key and values as intermediate record, capable of holding either of the sets of values. So the output of a mapper joins a key value to a list of values. So I said this works very well in case of one-to-one joining, where at most one record from every data set has the same key. So a special case of reducer join is called bucketing join. So bucketing join. So instead of mapping each, like what we saw the other time, when we have key as h base and the value as 1, we can have it in bucket. Say, okay, maybe there's a particular attribute. Okay, any variable that meets this requirement can be set as a key. In the mapper side that we did earlier, we are making it one-to-one. That is, to each element there's a corresponding value. But in a bucket list, it can be a group. It said a special case of reducer join is called a bucketing. In this case, that they might not have common keys, but support the notion of proximity. That means they are not far to each other. Like they carry the same property and characteristics. So how do the reducer side join different from a map side join? So we can do this on our own. So another thing we also have is what we call the links elevation example. These are just things we should just keep in mind, just to solidify our knowledge. It said the link graph and a terrain model converts two-dimensional link into 3 dimensions. So I don't have heard of converting to, let's say, higher dimension to a linear function. But in this case, you want to view a multi-dimension you want to move to a higher dimension from a lower dimension. That is moving from 2 dimension to 3. He said this process is called link elevation. Let's just keep them in mind and as we move on. So I think this is where I'll be stopping today. Please, you can read up on your materials. Try work on your practical class, especially to the data engineering guys and to the data analytics guys. Please, all the examples in our materials, they are simple. Let's just take time. If you can just give it 1 hour a day on your practical class, you will get them. You just get through in even in 30 minutes. You can get through with your lab. It's just type, copy and paste and test it, and you see that it is working, and you are there. So just make sure you have hands-on experience on the practical session and give it a try. I said, let's please the data engineering guys, please run through the practical class. Possibly on Wednesday, I can call you to come and to share your screen and at least do 1 or 2 things with us. And on Friday, you share, and or maybe you can, depending on how we feel to be good for us, but we can be called upon anytime to practice, to show what we'll be doing on our practical sessions. Please, and let us be up to date in our practical class. So don't let it be one-sided. Don't let it be skewed only to this class alone. Let's read up materials and attend to our practical sessions. So thank you very much. And if there is no question, I would like to call it a day. But if there's a question, if there's any question I would like to answer before I call it a day. Any question? Okay, so have a good day ahead, and thank you for coming around. We'll meet on Wednesday. Thank you, everyone.
Thank you, sir.
Thank you very much, sir. See you guys later. Yeah. Yes, take care.
All right. Emmanuel, please, how do you close the VMware space station? Hello?
Yeah. Have you logged in?
No, I did not log in, no.
What is showing on your screen?
Just the normal HD Adobe and then the normal HD user.
You just shut down. You go to the settings icon. Settings icon at the right top. That settings icon. You click on it. See.
Manuel, please, you can stop recording. Sorry, Adetor, Esther.
Yeah, you.
All these things Mr. Edward asked us to read up.
What did you say?
They are not all the things Mr. Edward asked us to read up.
Yes.
I'm sure they are not in our analytics material.
I guess so.
Okay, so when he was saying read up, he was just saying it. We cannot read up.
Well, are you sure they are not there? Okay. I think it's only our lab stuff that is different.
No, I think the text is actually different.
Richard is analyst. Marvelous account application. Well, I guess so. So I think it's only the engineering guys that can read it.
Okay.
Have you been able to shut down and log out? So log out and shut down.
Yeah. I will just shut down.
All right. Okay.
We have the same issues some people are having now.
I think all things being equal, you shouldn't.
Okay. Thank you, Esther.
All right. Bye.
Bye.